Alright, so basically, last few months I've been working on this smart motorcycle helmet, which mainly consists of a crash detection circuit that looks a little something like this. And considering that I had never even touched a breadboard or a soldering iron until at least a few months ago, I had bitten off a lot more than I could chew. And so I just wanted to make this video to sort of explain what I've done so far, and also like to help other people that want to, make cool circuits like these but have no experience and don't know where to start at all. And I mean, I get it, there's not that many resources out there when it comes to this kind of stuff. This is pretty niche. So yeah, this video is for those people. It's gonna be split into two parts. One is like all technical, and then there's gonna be like an anecdotal part at the end where I sort of explain my whole experience, trying to build this project. This video itself will be part of like a three-part sort of short series. It was just supposed to be two, but I'll get to why it's three later. So yeah. Okay, so the aim of this project is to create a crash detection circuit that's going to be embedded inside a motorcycle helmet. And to put it simply, what it's going to do is it's going to detect a crash. It's going to take the coordinates of the location of the crash, and it's going to send it via SMS and also make a phone call. In order to do this project, we're going to need a few modules. The first one is the Arduino Nano. This is like the beating heart of our project. It's what all of the modules get connected to. It's where we upload our code, and it's how we communicate with the other modules. Next, we have our MPU 6050. It's an accelerometer and gyroscope combined into one. The accelerometer measures the change in speed, and the gyroscope measures the change in orientation. This is what's going to allow us to detect the crash, because our sort of qualification for what is a crash is going to be based off of a sudden change in speed and orientation. Next, we have the Neo 6M GPS module. This is what's going to allow us to get the coordinates and then create a Google Maps link from those coordinates, which are then going to be sent over to our emergency contact via SMS using the SIM800L GSM module. This video, however, will only be covering the Neo 6M and the MPU 6050. Okay, so first we're gonna start with connecting the MPU 6050 to the Arduino Nano. Okay, I'm gonna first start by explaining how VCC and ground pins work on the MPU 6050, and also to that extent every other module, just so that you get an idea of how current flows around in a breadboard, and also some best practices when connecting modules together. Alright, so over here we have the VCC pin, and right next to it we have the ground pin. VCC is where power goes in, and ground is where power comes out, which then gives us a complete circuit. There are a few ways to power the MPU 6050. One of them being, for example, plugging in a battery directly into the VCC. But we're going to take a more practical approach, and we're going to power it through the Arduino Nano. When we plug in the Arduino Nano through the USB port to our computer, the computer will supply power to the Arduino Nano, which we can then use to power the other modules. If we take a closer look at the Arduino Nano, you can see that there is a 5-volt pin right over there and a 3.3 volt pin over there. What these pins do is that they take the power coming in from the computer and they step it down to 5 volts and 3.3 volts respectively. And because the MPU 6050 operates on 3.3 volts, we're going to be plugging in the 3.3 volt pin to the VCC of the MPU 6050. However, we aren't going to connect it directly to the 3.3 volt pin. Instead, we're going to use the power rails on the side. And I'm going to show you how to do that right now. If we take a jumper wire and plug in one end of it to the 3.3 volt and then plug in the other end to the positive power rail, what's going to end up happening is that that entire column right there is going to be charged with 3.3 volts. This power rail is going to allow us to take a wire, connect it to any of the slots in that power rail, and essentially take 3.3 volts and use it to power however many modules we want. Right now, since we only have one module, it does seem kind of pointless, but later on, as you'll see, when we add two modules together, we're going to need to use that power rail. So before we move on, we want to connect the ground pin of the Arduino Nano to the negative power rail, just so that we can complete the circuit. Okay, so now it's time to power the MPU 6050. We're gonna go ahead and plug in the 3.3 volts from the power rail to the VCC of the MPU 6050. And then we're gonna take the negative power rail and connect it to the ground pin of the MPU 6050. Now, if I was to connect the Arduino Nano to my computer, it would then power on the MPU 6050. Before we move on, however, we need to make sure that whatever readings we're getting from the MPU 6050, they're being sent to the Arduino Nano. So how we're going to do this is we're going to connect the SDA and SCL pins to A5 and A4 on the Arduino Nano, respectively. I should also add that it doesn't actually matter which A pin you connect it to. You could connect it to, A6 or A7. It doesn't matter. I'm just using A5 and A4 for this example. You just need to make sure that the code you're writing is consistent with the pins that you're using. So I'm using A4 and A5, and the code that I'm going to be running on it will also be using A4 and A5. Alright, so once you've connected the Arduino Nano to your computer, what you want to do is go ahead and open up the Arduino IDE. This is the programming environment that we're going to use to program our Arduino Nano. You can go and download it online. I'll leave a link in the description just so that it's easier for you. And when you open it up, it should look something like this. Alright, so up at the top, you're going to see select board, and you'll see an unknown board connected to the COM3 port. So we're just going to click on that. And in this example, we're using the Arduino Nano. So just go ahead and search Nano and click on Arduino Nano and confirm it. Alright, so now what we need to do is tell the Arduino Nano to take the readings from the MPU 6050 and display them on the serial monitor so that we can see if the readings are coming as they're supposed to be. Now to do this, we could write the code manually. However, there's a much simpler way, which is what I'm going to show you now. Alright, so in order to do this, we need to go to Tools and then go down to Manage Libraries, and then we need to download the MPU 6050 library. So just search it up and you'll see the second option, Adafruit MPU 6050. Just go ahead and download that one. Once that's done, we need to go to File and then Examples, and towards the bottom we'll see the MPU 6050, and we're going to use the basic readings example. Alright, so the same people that created the MPU 6050 have also created test code for us to use very conveniently. So now all you have to do is go ahead and upload this code to our Arduino Nano. Okay, so in order to see the output of the MPU 6050, we need to use the serial monitor. Now, the MPU 6050 has a serial connection to the Arduino Nano. And as the name suggests, the serial monitor monitors the data that is being transmitted from the MPU 6050 to the Arduino Nano. So the serial monitor works similarly to a radio in the sense that you have to tune in to the right frequency, the right channel. And when data is transmitted, it can be transmitted at different baud rates. And in this example, the baud rate is 115,200. So when we open up the serial monitor, we need to tune into that baud rate. Alright, so now we can see the readings on the serial monitor, and as you can see when I'm moving it, the readings are changing, which means that the accelerometer is working as it should be. Okay, so now it's time to test the Neo 6M GPS module. As you can see, on this one there's only 4 pins: VCC, ground, TX, and RX. As you can also see, I soldered the pins the wrong way around because I'm an idiot. So when I plug it onto the breadboard, it's gonna be upside down. Please don't make the same mistake that I did. Okay, so the RX pin on the Neo 6M will connect to D3 on the Arduino Nano, and the TX pin will be connected to D2 on the Arduino Nano. I'm just plugging in the cables before putting the GPS on because it's when I plug it in, it'll be upside down and I won't be able to read which pin is what. I also want to mention that the RX0 and TX1 pins on the Arduino Nano shouldn't be connected to anything because when you send the code to the Arduino Nano from the computer, it uses those pins. So if you connect anything to those pins, it's gonna interfere. So just make sure not to use those pins. Alright, so now we're gonna upload this very simple code that outputs all of the raw GPS readings from the Neo 6M. And if we take a look at our serial monitor, you'll see that a lot of the readings are blank. This is because the GPS has not locked on to a satellite, and so in order to fix this, you are gonna have to go outside, which might be difficult for a lot of you considering that you're either CS or electrical engineering majors. Just go outside somewhere where there's a clear, unobstructed view of the sky and just stand there for a couple of minutes until the Neo 6M locks on to a satellite. Okay, so here I am on the roof of my house in the scorching Jeddah heat, and as you can see, we're getting complete readings from our GPS. Okay, so now that we've tested each module individually and we know that they work, it's now time to combine both of those modules. Okay, so what we're gonna do is connect the MPU 6050 and Neo 6M both to the Arduino Nano. After that, we're going to write a crash detection algorithm. The algorithm will constantly take inputs from the accelerometer, and if it detects a sudden change in either speed or rotation, it's going to classify that as a crash. Once that happens, we're going to take the coordinates from the GPS to create a Google Maps link of the location of the crash. Okay, so we're going to connect the MPU 6050 the same way that we did earlier in the video. So that being the VCC is connected to the positive power rail, the ground is connected to the negative power rail, SCL is connected to A5, and SDA is connected to A4. Okay, so before we upload the code, I just want to run through it quickly. Over here, we have all of the libraries that we're using in this code. This line over here determines the sensitivity, meaning if we were to lower this, a small change in speed would be detected as a crash, and if we were to increase it, a greater change in speed would be needed to detect a crash. So normally this should be like 2 or 3, but for testing purposes, I've lowered it down to 1.25 so that I don't need to shake it as aggressively in order to test the crash detection functionality. Over here is the main code. So while the crash has not been detected, we're going to constantly output the acceleration values in terms of g being 9.81 gravity. Over here, if the total acceleration exceeds the threshold, we're going to classify that as a crash. Over here, this is where we constantly read the values from the Neo 6M and store them so that when a crash is detected, we can use those values for the Google Maps link. Over here, once the crash is detected, we're going to create a Google Maps link using the latitude and longitude from the Neo 6M. Okay, so now we're gonna go ahead and upload the code, then head outside to test it. Alright, so we're back up on the roof to test this. As you can see, I've already tested it once, but we're just gonna run it again. So if you didn't know, there's this button on the Arduino Nano, a reset button. If you just click that, it's gonna run the entire code again from the beginning. Okay, so as you can see, we're getting acceleration readings. So I'm just gonna go ahead and give it a little shake. And there we go, now I've doxed myself. Okay, so for those of you that are in a similar situation to me, meaning you have some cool ideas for some circuits you want to make, but you're not exactly sure where or how to start, I'm just going to tell you about how I went about it, and maybe that will be of some help. The first step is to have an idea, right? So over here, I have this Garmin Instinct 2S. It's a fitness watch, and one of its features is that if you're riding a bike while wearing it, and if you fall off the bike, it's going to send an SOS signal and also a message, an emergency contact with the location of where you fell off. So I'm really into motorcycles, and that's because my granddad used to take me out on rides all across Jeddah when I was younger. Now that I'm 18, I'm practicing how to ride a bike myself, and inshallah soon I'll get my license as well. Now, usually motorcycle crashes are more lethal than bicycle ones. So I thought, what if we took this concept and put it inside a motorcycle helmet? That is where the idea came for me to make a crash detection circuit and then put it inside a motorcycle helmet. The next step is then to research and acquire all of the different parts that you need. So in my case, if I wanted to make a crash detection circuit, I needed something to first detect a crash, that being through a change in speed and rotation. So I would need an accelerometer and gyroscope. The MPU 6050 is both of those things combined, so that's very convenient. Next, I needed a GPS, So I went with the Neo 6M because that's the most popular one. I also needed a GSM module in order to send SMS messages and make phone calls. For that, I went with the SIM 800L. Again, because of its popularity and also because of its small form factor. I recommend going with the more popular modules because they tend to have more resources, which is very useful if you're doing this for the first time. Then I needed to research how each part worked. And the best way to do this is to just search it up on YouTube and watch a bunch of videos that explain, what the different functionalities are, what each pin does, all of that kind of stuff. Now, all of these modules, they come with the actual board and some pins. Now, you need to solder these pins onto the board. That means learning how to solder. This is a very, very essential skill if you're going to pursue a career in anything related to electronics. So yeah, go ahead and buy yourself a soldering iron, some like a roll of solder. Get also this thing right here. It's this copper sponge so that you can clean your soldering iron when solder gets stuck on it. My next piece of advice would be to take things slowly. This goes for, when you're studying how these modules work, you should really spend a lot of time trying to really understand, because a lot of the time you're gonna be spending troubleshooting because things are bound to go wrong. And unless you have like a deep understanding of how everything works, it's gonna be very difficult to do that. Another thing would be to test each piece individually, just like I did in this video before I combined the MPU 6050 and Neo 6M. I connected each part and only that part to the Arduino Nano and ran some test code on it to make sure it works. This is because later on you're bound to run into some issues one way or another. And if you do this, you can start crossing things off the list of what to check when things go wrong, when you're troubleshooting. And that also leads into my next bit of advice, which is that it is never going to work on the first try. Things are going to break, things are going to just not work for seemingly no reason, and you just have to be patient, step back, and try and figure out the problem. And so just keep that in mind when you're making these things, so that you do it in a way that ensures success. So for example, testing each part individually. Once I know something works, then I can move on to the next step. So that way, if something goes wrong in the next step, I know where to look. This is also the reason this project took a lot longer than I expected. The MPU 6050 that I originally bought in Pakistan, when I plugged it in, it was just returning all zeros on the basic readings. And so I was just stuck on that for a couple of weeks trying to figure out what's wrong. And I tried a bunch of stuff like checking the connections. I went on Google through some old Stack Overflow forums, but nothing really seemed to work. And I ended up buying another one, and alhamdulillah, that worked just fine. I also read somewhere that these MPU 6050s, they don't make them officially anymore, and that there's a lot of fakes out on the market. So maybe that was the reason. I'm not too sure. So just be careful where you're buying from. I'd prefer to buy from like a local shop nearby, but this might be difficult depending where you live. But most places should have at least one store with these electronic kits. This is again also the reason that I split this video into 3 parts, because this SIM 800L, which is what's supposed to send the SMS message, for whatever reason, I'm not sure why I can't get it working. So inshallah, when I do get it working, that will be the next video where I add this to the GPS and accelerometer. And then after that, I'll try and sort of integrate this into the motorcycle helmet and then test it that way. So yeah, I mean, you're definitely bound to run into a lot of roadblocks on the way, and my advice would be to just stay patient. And I mean, honestly, once you do get this thing working, trust me, there's no greater feeling. So yeah, I mean, hope that helps, and thanks for watching.